Hello, welcome back to another STATA tutorial. So today we're going to start learning about creating descriptive statistics. Um, so while it's simple to do this work using small data sets by hand at the beginning, so when you are just starting out to learn econometrics or statistics, you probably have already learned how to calculate the mean and the median and the standard deviation, the covariance, the correlation coefficient, so on and so forth. It's important to calculate those by hand at the beginning, but in order to gain a full understanding of the dataset when you're looking at a large dataset, hand calculation can be extremely difficult and time consuming. So the good thing is data analytics software such as STATA has simple tools to provide us with the information we need about our data, and that is what we're going to learn today. So before we start anything, let's make sure that all the checklist is being done. So make sure your Stata is installed and operational. And you're going to download topic 3 folder from the Stata data repository and save it onto your desktop. And then we're going to double check that a folder has all the files in it. And then after that, start a new do file. Always remember, every time you start a new project, you always create a new do file so that you don't confuse yourself or your future self. And then you're going to save it and title it topic 3. Or you can title the column whatever you want. And then write the first 4 lines of code. Remember, these 4 lines of code are there to help you gain a footing of a good Stata project. So the first 4 lines of code are always clear. CD, change the working directory to your current working directory, capture lock close, and lock using topic 3, and make sure you add the append at the end to make sure that every single session of your project gets added to the log file instead of being overwritten. And then also make sure the first 4 lines of code run. So I can show you on my computer. So this is my topic 3 folder. You can see that I have all of my all of my information here. And then if I open Stata, you can see that my first 4 lines of code are already there. Clear, CD, capture, log, close, log using. Again, so the only thing that you need to change is this part because the working directory on every computer is different. You just need to make sure that you know exactly where the working directory of your current folder is. All right. And if you need time to get this ready, please pause the video. And then when you're ready, unpause the video and we're going to continue. Okay, considering everything is working, there are two really simple codes that we're going to learn today. The first one is summarize, and the second one is correlate. So we're going to learn how to use those codes. So the summarize is there to give you the summary statistics, what we call information about a specific variable or about a list of variables. And the correlate is a command that shows you the correlation between variables. Just by looking at the name, you can probably guess what they do, right? So the first code is, or the first command is summarize. So just to help us understand this a little bit, go to the command window and just type help summarize. And you're going to see that this is the syntax. So the syntax is very simple. Summarize, and then you add the var list, meaning the list of the variables that you want summary statistics of. And then you can add any kind of if or in restriction, and then you add your options. So the most important option we're going to learn today is this detail option because the detail option gives you the median of a variable. The general summary statistic table does not really give you the median of a variable. Okay, so very simple, and we're going to learn how to do that. In order to learn how to do that, we're going to open the only dataset we have in this folder, which is the county dataset. Actually, the county dataset that we use here is actually just the dataset that we've been using in the previous class, in the previous tutorial. It's still the panel dataset for all the counties in the United States. So we're going to open the dataset by typing use county.dta, and we're going to click do, and the dataset is being loaded. And if you just look at the dataset again, this is again all of the counties in the United States from 1990 all the way to 2010. So 30 years, every single county. We have a lot of informations. So one of the most important information about a county is actually the GDP, which measures the total income, annual income of a county, the wealth of a county. right? So I want to gain more understanding about the GDP of each county. So I'm going to focus my attention onto this GDP total variable. And if you want to look at the label of this variable, you're going to see that this is the GDP of all industries measured in chain 2012 dollars, which means it's a chained real GDP, and is measured in thousands of dollars. It's always important to look at the label of a variable to know exactly how the variable is being measured and being defined. Okay, so now I'm going to learn how to get a summary statistic of the GDP total. Very simple. Just type summarize GDP underscore total. And if we click do, you're going to see that now the results window has shown us a new table with some important information about this variable. First of all, we know how many observations there are. There are about 61 observations across all the counties in 30 years. And we also know where the mean is, where the standard deviation is, the min, and the max. So we know the poorest county's GDP. Remember, this is in thousands of dollars, so this is $6.3 million. And then we also have the max. Okay. And then if you have the standard deviation, you can calculate the variance of this variable. Remember, the standard deviation is just the square root of the variance. So if you want to calculate the variance, just uh, square this and you're going to get the variance. Okay. So this is how we understand or how we use summary statistic, summarize command to get a summary statistic of a variable. But wait a minute, we don't know the median of GDP total. Sometimes the mean is good enough to show us the central tendency of a variable, but sometimes we also want to know the median just to know the skewness of a variable. So how are we going to do that? Well, it's very simple. We just add a option of detail. You can also type D if you want to. I'm typing detail just for good measure. So if I click do, you're going to see that now there's a more detailed descriptive statistic of this variable GDP total. And all of the information that we had in the previous table is still here, number of observations, mean, standard deviation, and now we have the variance. We don't actually have to physically calculate the variance using the standard deviation anymore. And most importantly, we're going to look at the mean here, which is the 50th percentile of a variable. And here, this is the median. So we have the median, we have the mean, right? And you can see that the mean is a lot bigger than the median, which means that when we're looking at the GDP of different counties, the mean is a lot bigger than the median, which means the distribution is skewed to the right. Okay, it's a positive skewness. All right. So this is how we understand summary statistics. Well, maybe sometimes we're thinking, okay, I want to know the summary statistic of the variable such as GDP total. I also want to look at the summary statistic of the population, right? This is the population of each county, population underscore BEA. Do I need to have two separate commands to type summary GDP total and summary GDP population? No. Remember, the help file tells you that after the commands summarize, we can have a list of variables. So what I want to do is very simple. However many variables that you want to look at the summary statistic, all you need to do is to type the list of them. So if I want to look at two different variables, all I need to do is look at the GDP total and the population BA, and if I click do, you can see that now I have a table of summary statistics between these two variables. Okay. What about I want three? Well, very simple. Type summarize GDP total, population underscore BA. And maybe the third one I want to look at is the unemployment rate of a variable. So I think the overall unemployment rate variable is just called unrate rate. So UNEMP underscore rate. So this is the uh, unemployment rate from the Bureau of Labor Statistics. So I'm just going to add UNEMP rate. So if I click do, now, well, there's a typo. So we need to correct that typo. If we click do, now we have the summary statistics of three different variables, right? So we have the GDP total, population, unemployment rate, and you can see that this unemployment rate is measured in percentage, and that is why for Sam County, the county with the lowest unemployment rate is actually 0.5%. And the county with the highest unemployment rate is about 40%, which means 40% of the labor force are unemployed, which is a pretty big number, right? So we can look at all of this information to gain an understanding of the data set that we're looking at. Okay, so this is summarize. The next thing we're going to learn is correlate. So instead of looking at the unique characteristics of each variable, now I want to look at the relationship between different variables. And the code to do that is correlate. So we're going to type help correlate in the command window just to gain some kind of understanding of the syntax of correlate. And you're going to see that the correlate syntax is pretty much the same as the summarize syntax, which is just type correlate and then the list of your variables. You can add your if or in command, if and in restrictions, and then you can add your options if you want to. So one of the options that we're going to be looking at is this covariance option. Okay, so again, very simple. I just want to look at the relationship between two different variables, and all I need to do is to type correlate. And for example, I want to look at the correlation between GDP total and the population. And all I need to do is to click do, and you can see that now STATA has given me a new, what we call a correlation coefficient matrix. So this correlation coefficient matrix gives you the information about the correlation coefficient of all the pairwise variables within your list. So if you want to look at the correlation coefficient between GDP and population, which by the way, the correlation coefficient by definition stays within +1 and -1. If it's positive, it means a positive correlation. If it's a negative, it means a negative correlation. Okay, so if I want to look at the correlation coefficient between these two different variables, all we need to do is to look at the GDP total and the population. So the first column, second row, this is the correlation coefficient. It's 0.8962. It's relatively close to 1, which means the relationship between the population and the GDP of a county is pretty strongly positive, which makes sense, right? Because if you think about it, the counties that are more populous are usually the counties that are richer because you have more people producing things and earning income, so their GDPs should relatively be higher, right? So that is how we look at the correlation coefficient. Maybe I want to look at the pairwise correlation coefficient of three different variables. And all I need to do is, again, same thing, correlate, and then all the variables I want. And you can see that now there is a pairwise, a 3 by 3 matrix that gives you the correlation coefficient. So again, the correlation coefficient between GDP and population is 0.8962, just like what we see here. So nothing changed. And the correlation coefficient between GDP total and unemployment rate is a negative number, but it's relatively close to 0, which means that we don't really see a strong negative linear correlation. There might be nonlinear relationship, we don't know, but it doesn't look like there's a strong linear relationship. Same thing, if I want to look at a relationship between population and unemployment rate, and you can see that the number is positive, but is relatively close to 0. Again, it doesn't mean that there is no relationship between the population of a county and the unemployment rate of the county, but uh, the relationship might just not be linear. Okay. And if you look at the diagonals here, you're going to see all the diagonals are 1, 1, 1. And the reason that we see the diagonals being 1 here is because we're looking at the correlation of a variable with itself, right? So the first cell here, first column, first row, you're going to see 1 here, which means it's the correlation coefficient of GDP with GDP. And as you know, correlation coefficient stays within -1 and +1. So you can interpret this as GDP is 100% positively correlated with GDP itself, which means that if GDP deviates from the mean by 1 unit, GDP is gonna deviate from the mean by 1 unit. Okay, 1 for 1 deviation. So same thing here with the population and same thing here with unemployment. And correlation coefficient is a very important metric to use because we get to compare different correlation coefficients between different pairs of variables. But sometimes we might just want to know the covariances between different variables. And all we need to do is to add the covariance command. So you can type covariance if you want to. I'm lazy. I'm going to type C at the end as an option. So if I run this line of code, you're going to see that now the table has changed. Even though the signs between different pairs are exactly the same, the numbers have changed. And the reason is because we're looking at the covariance. The downside of the covariance is that you can't really compare covariances of different pairs of variables just because they're scale different and their means are different, they measure different things. So you can't really compare them. Just because the correlation, the covariance is bigger doesn't mean the relationship is stronger. But if you want to look at the covariance, if you want to calculate the covariance, you can do that. And on the diagonal, these numbers are actually just the variances of each variable. So you see how here the GDP variance is 4.8 with 14 zeros at the end. We can actually go to the detailed summary statistics. You can see that the variance of GDP is just 4.8 with 14 zeros after that. Okay, so this is probably the simplest lecture that we have. Just summarize and correlate to look at the characteristics of individual variables and the relationship between different variables. So just because this is relatively simple, I have provided a practice question for you guys to just have a general understanding of what we're doing to practice. So if we go to the table, if we go to the folder, you're going to see there is a document called Topic 3 Practice Set. So if you open this topic 3 practice set, there are some questions for you to experiment to get some kind of understanding about how to calculate the descriptive statistics of different variables. You're still using the same data set, so you can actually just use the same do file and just continue to do this if you want to. But try these things out, and the answer key is here. The answer key is provided for you, and the answer key do file is also provided for you. I just want to make sure that you guys know that you have the correct information. But at the same time, I want to say that you guys probably want to do your do file first before you look at my do file. Okay? But one thing I want to emphasize here is that if you're looking at this practice question, you want to pay close attention to what these variables are. So first of all, here is asking you to calculate the summary statistic of the GDP in millions of dollars. But if you look at the data set, you're going to see that the GDP total is measured in thousands of dollars. So you need to create a brand new variable to try to get a new variable that measures the GDP in the millions of dollars. Okay? So you need to also use the information that you learned in the previous classes to learn how to generate a new variable. At the same time, here we have the share of the GDP from agriculture and the share of the GDP from manufacturing. So these are the percentages of the GDP that belongs to agriculture sector and the percentages of the GDP that belongs to the manufacturing sector. So if you look at the data set, we have the GDP that's in the agriculture sector and the GDP in the manufacturing sector, but we don't have the percentage. You need to calculate the percentage, right? We have the total GDP of a county, we have the GDP of the agricultural sector. So all you need to calculate as a share is the GDP agriculture divided by GDP total. Okay, so these are all the hints I'm going to give you. Uh, Good luck and have fun practicing. And I'll see you in the next tutorial. Thank you.